Okay, now that we learned why we need to factor and then how to find the roots of a given quadratic trinomial, let's see the techniques how to get from the equation into the factors. Earlier we saw that the factors of x squared plus 5x plus 6 is actually x plus 2 and then x plus 3. So how do we get there? Well, let's go ahead and then apply the box method in this case. Okay, remember this one is a leading coefficient of 1. When it is 1, it is relatively easy. Okay, so let's start with that one. The first thing that we need to do is we're gonna create a little tic-tac-toe box. This is like the box method. Okay, and then we're gonna cross out this top corner because we don't need it. It's a product, it's a multiplication, so we don't need it. Okay, now we're gonna, after we do this, we're gonna fill up the diagonals. Okay, but the question is, what are we actually gonna fill up the diagonals with? Now, the center of the tic-tac-toe box is always the first term or the leading term. In this case we do have 1x squared, so I'm just gonna plug 1x squared here. Okay, and then the bottom corner is always gonna be the last number. Okay, so in this case what we have here is this number always goes in here, and then this number always goes in here. So let me repeat this one time. The leading coefficient, the leading term goes inside the center of the tic-tac-toe, and in the bottom corner we have our C that always go there. Okay, all right, now once we do that, what we need to do is figure out how to fill up the rest of this tic-tac-toe box. Okay, so at the end we're gonna end up with two numbers here, two expressions here, and then two expressions here. Those would be our factors. Okay, after we have our diagonals, let's find the factors of 6. Okay, so I'm gonna go ahead and then write that one here, factors of 6. This is including the negative. Okay, what times what gives us 6? Well, 1 times 6 is the first one, 2 times 3 is the second one, and then the negatives are gonna be 1 times 6 and negative 6, and then negative 2 times negative 3. So these are all the ones that gives me 6 when I multiply them. Out of these we're gonna choose one of the two combinations, and then the combination has to be or need to be 5 when we add them. So if I add 1 plus 6, I get 7. So this is out of the question, so I'm gonna cross him out. Okay, what about 2 plus 3? Well, 2 plus 3 is gonna be 5, so it actually gives me 5. So this is right now. Once you find the two numbers, you don't necessarily have to worry about the other ones. So I'm gonna go ahead and then use these two numbers. Okay, now does it matter where I put these two numbers? Well, instead of leaving these two spaces empty, I'm gonna fill them up with 2x, and I'm gonna go ahead and then put this in blue, 2x right here, and then 3x. Now doesn't matter if I put 3x up there and 2x down here. No, not at all. At this point it doesn't really matter, because we're just interested into the combination of the two that adds up to 5 and they multiply it to 6. So always this is how I check. This is 6, so 2 times 3 times 2 would be 6, and 3 plus 2 would be 5. When I multiply the two numbers, it gives me this. When I add them, it gives me that. Once we get these two numbers, then we're gonna figure out to fill these two last corners. What times what gives me 6? I'm gonna use the factors. The factor that I used were 2 and 3. So if I put 2 here, we're gonna have a little problem here, because 2 times what gives me 3x. I have to use a fraction, so it's important that we put the 2 right here. Or you can also use the factor of 2 and 6, whichever one. If I put 2 there, 2 times what gives me 6? 3. So that goes right here. 2 times 3 is 6. Now that we know this is 3 and then this is 3x, what times 3 gives me 3x? Then we know it is x, because x times 3 is 3x. And then the last thing is, what times 2 gives me 2x? 2 times x. Or we can also get x times x gives me x squared. Now we do have our two factors, which are x plus 2 and then x plus 3. And then this completes the box method to find the factors. Once you find the factors, you can easily find what makes them 0 by looking at this. X plus 2, x has to be negative 2 right here. X plus 3, we need x to be negative 3. Okay, another way to do this one is using sum and product. I'm just gonna carve a little bit space right here and then write this equation: x squared plus 5x plus 6 is equals to 0. Now this sum and product technique works for any kind of coefficient for x squared, but the technique that I'm going to show you next only works when the leading coefficient is 1. So I'm going to make sure that this is 1. Okay, now I write sum right here and then product. The sum always needs to be the middle term, no matter what it is. If it is positive, the sum needs to be 5 in this case. If this was negative 6, this should be negative 6. If this was negative 10, negative 10 there. The sum is always the b term. But the product is the product of the leading coefficient and then the constant term, which is always 1, in this case 1 times 6, which is 6. But if this was 5, we should use 5 times 6, which is 30. Now once we do this, we look for the factors of 6 again, the same way we did in this one, which is 1 and 6, 2 and 3, negative 1 and negative 6, negative 2 and negative 3. Now, as the name implies, the product is a multiplication of two things and the sum is the addition of two things. So we're looking for two numbers. When we multiply them, we get 6, and then when we add them, we get 5. And then two numbers are going to be 2 and 3. Now, here's where it gets interesting. If the leading term is 1, then we can just do x plus whatever one of the numbers was, which is 2, and then times x plus whatever the other number was, 3, which is x plus 2 plus x plus 3 is the same thing as the one that we found right here. This seems relatively easier, which is fine, but it gets a little tricky when the leading coefficient is not 1. If the leading coefficient is not 1, we cannot do this. We can't get from here to here. We gotta do a couple of extra steps. Okay, we're gonna do a couple of other examples in the next video.